Welcome back to my part 2 video covering an in-depth description of 6 major machine upgrades to my custom 3D printed CNC that I completed in December. If you have not seen my CNC part 1 video, I encourage you to watch that one first so you're all up to speed with how I built it and the current project status. In that video, I demonstrate the complete design process of how I designed, manufactured, assembled, and set up the machine to run Gerbil using an Arduino Uno paired with a CNC shield. So to kick off the upgrades, my first and most extensive update was my redesign of the ZAxis Gantry. Due to the wobbling problem in my previous design using the C-beam profiles with V-wheels, I knew I had to come up with a more solid system that could easily be added to the current machine. To do this, I decided to use 2 cylindrical rails that were 12 millimeters thick and 300 millimeters long. Generally, by using these linear rails, there should be no directional movement in the X direction, which would be perpendicular to the rails. Also, by having the ZAxis chassis making 4 connections to the rails, this further emphasizes rigidity in the structure. Along with the cylindrical rails, the other main components of the updated assembly include the 4 slide blocks, a 3D printed backplate, a new NEMA 23 mounting bracket, a new bearing collar mounting bracket, and a new brass nut mount for the brass nuts that drive the chassis with the 300mm lead screws. The replacement plastic parts were all printed using PETG. These parts and all the other STL files for the machine will be downloadable on my Patreon page, which is linked in the description. As a whole, after installing the new ZAxis subassembly, it both looked and felt more sturdy. However, there was still a small wiggle in the forward-backward direction. This was largely due to the 3D printed backplate being both plastic and printed in 2 separate pieces due to the print volume constraints. To correct this issue, I took the CAD model of the backplate and created a CNC toolpath for aluminum. Then, with 3/8" aluminum stock, I milled the part using my CNC. With this being my first experience milling aluminum on this machine, I would say it overall went okay. If you are planning on building a 3D printed CNC, I do think it's important to have this aluminum backplate to improve structural stability. Therefore, one way to do this is to make a temporary 3D printed backplate and soon after that, mill out an aluminum backplate which you can then install in place of the temporary file. The other option is to find an online aluminum CNC manufacturer to have the backplate made upon first assembly of the machine. This possibility points to the sponsor of this video, which is PCBWay. PCBWay is an online prototyping manufacturer for either small or large quantity orders, where makers can import Gerber files, CAD files, and various design configurations. Not only featuring the ability to customize standard and flexible PCBs, but PCBWay offers 3D printing services, CNC milling of tons of different materials, sheet metal fabrication, and even injection molding. By simply going to their website, selecting the type of parts you're looking for, and importing your custom files, PCBWay will ship professional grade parts right to your door. Get an instant quote now on PCBWay.com, link in the description. For my second major upgrade, I decided to create a threaded wasteboard to make the unloading and offloading of stock easier. Previously, I had completely relied on screwing down each stock piece, which was both time consuming and frustrating. So to solve this problem, I purchased 50 threaded inserts that were 1/4 20 inches in size, which could be evenly spaced across my wasteboard. Then, after creating a cam toolpath for my CNC on Fusion 360, I had my machine cut out the 3/8" holes so the inserts could be placed. As a whole, it's now much easier to add and remove tension of various clamps to save time in the CNC process. Speaking of clamps, I designed a whole assortment of different clamps and printed them out of PETG. Of the most common type, I created multiple versions to accommodate for different heights of stock. I also created 2 cam clamps, which can be easily twisted to secure or remove the cutting material. Lastly, I designed and printed a zero corner, which is screwed in place into the wasteboard. With locations for threaded inserts, this zero corner will allow me to have a consistent zero position while also applying clamps near the milling location. If you're interested in downloading these files, they are all featured on my Patreon page in a separate post. To improve the safety and repeatability of milling in relation to the zero corner, I decided to add limit switches, which will allow me to home the machine. With the use of the CNC shield connected to the Arduino, connecting limit switches is made simple by plugging in the wires to the specified locations on the shield. Although having limit switches is not required on a DIY CNC, I do recommend it so that both you and your machine know where the machine is in physical space. My fifth machine upgrade solved the dust collection problem, which is important when milling on a CNC. In fact, if you don't have an active dust collection system, you either have to sit and follow the bit around with a shop vac, or you can make the mill plow through sawdust, which can cause problems. Therefore, I decided to design and 3D print a custom dust shoe that would mount to the 500 watt spindle and a shop vac hose. Also, whenever I need to access the spindle or change the bit, I can easily remove the bottom section as the two pieces are held together by 3 to 5 mm cylindrical magnets. For the clear brush material, I decided to use some leftover clear plastic that is flexible and it works quite well. Once again, if you want to create your own dust shoe, the downloadable STL files are available on my Patreon page. Coming to my last and final upgrade, I decided to implement a ZPro Module, which could be easily plugged into the CNC shield. Also, with an easy to use CNCJS ZPro widget, all you have to do is measure the thickness of the probe, install the probe into this fancy holder on my zero corner, and press probe. Then, your machine will slowly lower until it completes the circuit by touching the probe, in which it retracts to a safe height. In the future, this function will save time when prepping for CNC cuts. As requested by many of you in the comments on my last video, you guys wanted to see how my machine matched up against both poly and aluminum materials. Therefore, as I covered in previous segments, for the ZAxis backplate, I milled it out of 3/8 inch aluminum stock. Also, I milled out various other parts out of MDF, plywood, and poly to test the machine's ability. Ultimately, at the end of tracking these different materials, I created a small attachment that goes around the spindle potentiometer, and this marks what speeds correspond to what materials. Along with providing my top DIY CNC upgrades, I wanted to give you several recommendations if you want to build a 3D printed CNC yourself. First, I strongly recommend printing the parts out of PETG instead of PLA. Currently, I'm a little scared to move my CNC into the garage, as it will then be exposed to extremely hot and extremely cold temperatures. This could potentially cause deformation and weakening of my PLA parts. Therefore, if I ever remodel my CNC, I'll be sure to use PETG or a different temperature resistant material. Second, make the Z-axis only as long as it needs to be for easier manufacturing and improved stability. A 3-inch range should be plenty, as you rarely cut out parts out of stock that is thicker than 1 inch. Third, do your research before just downloading the files and buying parts. With CNC machines being on the higher end in terms of price, you should carefully consider how much you want to spend, what skills you have, and what reasons you want the CNC. I put a list of several videos to check out related to 3D printed CNC machines in the description below. Lastly, and most importantly, ask yourself, why do I want this machine? If you want to design your own machine to enjoy the process and tinker with something new while saving money in the process, I'll say go for it. But if you're building your own just to save money, or if you want a CNC so you can start selling woodworking projects, save yourself a headache and buy a commercial option. Thank you for being a supporter of my channel by watching this video, and if you'd like to join my project journey moving forward, it would be great for you to subscribe. Also, the STL files for this project will be available in my Patreon page, which is linked below.